Kia ora, and welcome to a lesson on Cambridge Mathematics P3 Integration by Parts. Integration by parts is basically a reverse product rule, and it allows you to take a integral such as x e to the 2x, which has no straightforward integration, and treat it like a product rule question and reverse it. So first thing to do is just have a quick recap of the product rule. So the product rule y equals uv, when differentiated to dy by dx, will produce u dv dx plus v du dx. And what we can do is we can basically say that this here is u and dv dx, and with a bit of rearrangement we can use this to find a way to integrate that function. So let's have a look at what the integral of u dv dx plus v du dx would be. So that would actually just be uv. So what we can say is uv is equal to the integral of u dv dx plus the integral of v du dx. So if I just want the integral of u dv dx, I would be actually trying to find uv minus the integral of v du dx. Okay, and that will give me the integral of u dv dx. So thinking about that and this question here, let's have a look at what that might look like. So if my x is equal to u, so if I've got u is equal to x, and I have dv dx is equal to e to the power 2x, well, du dx is 1, and v, based upon my integral of e to the 2x, would be a half e to the 2x, because e to the 2x, well, e to the x integrates to e to the x. E to the kx is 1 over k e to the kx, because you have to differentiate by the basically the differential of the power. Okay, and because I know that the integral of u dv dx is equal to uv minus the integral of v du dx, then the integral of x e to the minus 2x is going to equal x e to the 2x. It's going to equal u, which is x, times my v. So x times a half e to the 2x minus the integral of v du dx, which is going to give me the integral of half e to the 2x times 1, because du dx was 1. So this is going to become half x e to the 2x minus the integral of a half e to the 2x, which is going to become a quarter e to the 2x plus c. Okay, and that is the final solution, because there's no simplification that can be done here. So you can't directly integrate x e to the 2x, you've got to break it into these parts and then use a reverse product rule situation to solve. Okay, but when doing these you do have to be careful. So we're going to look at x log x, and when I say you've got to be careful, it's deciding which one of these two terms is going to be u and which one's going to be dv dx. Okay, we do not have a direct integration of log x, so if I was to call this log x v dv dx part, I would not be able to change that to v, okay, because we don't have a direct way of doing that. So instead, what I'm going to do is I'm going to call the log x bit u, and I'm going to call the x bit dv dx. So u is log x, dv dx is x, and now when I do my du dx, that is going to become 1 over x, and my v is just going to become half x squared. Again, I'm going to use the by parts rule, so x log x is going to become uv, so that's going to become a half x squared log x minus the integral of v du dx, which is 1 over x times half x squared, which can be simplified. So this is going to become half x squared log x minus a half x, sorry, the integral of a half x. And then when I integrate this, I'm going to end up with a half x squared log x, add 1 to the power x squared, divide by the new power, minus a quarter x squared plus c. Okay, I could do a bit of taking the x squared out of those two terms, creating a little bracket, but it wouldn't be worthwhile at this point. And that's the solution. Let's have a look at a third example. This time, we're just going to look at the integral of log x. And as I said a second ago, we do not have a direct way of getting the integral of log x. So one of the fun things we can do with this is we can consider log x as 1 times log x, and do the same thing I did a second ago, where we're going to call this term u, this term dv dx. So we're going to get u is equal to log x, du dx would be equal to 1 over x, and then if dv dx is equal to 1, then v must be x. So the integral of log x is going to equal uv, so log x times x, so x log x, minus the integral of v du dx, which is x times 1 over x, which is just 1. And this is going to give me x log x minus x plus c. So technically, the integral of log x is actually x log x minus x plus c. Let's have a look at a fourth example. We're going to do x squared sine x. Okay, this one's going to be interesting, and you'll see why in a second. So I'm going to start off by saying let u equal x squared, which means I'm going to be saying dv dx is sine x. Okay, so du dx could be 2x, and v would be minus cos x. When I do the integral of this now and do it by parts, x squared sine x is going to become uv, so minus x squared cos x minus the integral of v du dx, which would be minus 2x cos x. You might see a problem here because I've still got an integral which I can't do because I've got two terms times together. So this is the interesting bit. I can again think about this part here as u and dv dx. This time I'm going to call the 2x u, I'm going to call the cos x dv dx. So now u is equal to minus 2x, dv dx is equal to cos x, so du dx is minus 2, and the v dx becomes v is equal to sine x. So, hopefully this time, because when I differentiated my u minus 2x, it became minus 2, we're going to end up with a situation where we can actually integrate, because we're going to do our minus 2 times sine x will be the integral part. So, in one long stream, the integral of x squared sine x is equal to minus x squared cos x minus my new uv. So uv is minus 2x times sine x, so actually that's going to change that to plus 2x sine x minus the integral of v du dx, which is minus 2 times sine x, so minus 2 sine x. Now I've got no extra x term in here, so I can actually integrate that. So this is going to become minus x squared cos x plus 2x sine x, and then minus 2 sine x integrated with respect to x is going to give me plus 2 cos x, but there's is going to give me negative 2 cos x, but there's a minus in front, so that's going to become plus 2 cos x plus c. So this is a integration by parts where you've got to do it twice. Okay, you can keep doing it until there's no x term times some other term involving x. That's all for now. Hopefully this will allow you to answer some questions on this, and good luck, and I'll speak to you again soon.